Good morning, Mr. David and all students. So today we are going to be discovering the world of 2D and 3D shapes. I'm Lyn Syuen. I'm Trixie.
I'm Qi Hui. I'm Pek Jun Kai.
I'm Aidan. And I'm Yu Zhe. So this is our table of contents. We'll include chapter 10.1 until chapter 10.7. Chapter 10.1 is points, lines, and angles. Chapter 10.2, parallel lines, perpendicular lines, and related angles. Chapter 10.3, congruent figures. Chapter 10.4, line symmetry. Chapter 10.5, rotational symmetry. Chapter 10.6, polygons and circles. Chapter 10.7, 3D shapes, size, and elevation.
So the first topic of today is points, lines, and angles. Okay, so the first subtopic we're talking about is points. So points are a primitive notion that models with the design of position in space and has no length and vectors. So in the picture here, we can see this is point A and this is point B. So if you see a dot on that, then this is called a point. The type of point is also called vertices, which is a point where two lines meet either at an angle or horizontal. This is or. So this is a vertex or polygon. So like here we have the quadrilateral and then this is a vertex. Sorry. Okay, so this is the second subtopic we're talking about is lines. So a line has only length but no width and extends to opposite directions infinitely. So this is an example of a line and it consists of a line segment, array, two endpoints, and an origin. Multiple straight lines can form relationships such as parallel and perpendicular lines. Two straight lines can combine to form an angle like this. So the last subtopic we're talking about is angles. So angles consist of these parts. One vertex and two arcs. The vertex is a point where the multiple where two lines meet here. And the arms are lines that make up an angle. The arm that forms a piece of the angle is called the initial side. While the side up to which the angle is measurement is done is called the terminal side. So this is a point, this is a line, and this is an angle.
And now I'm going to talk about chapter 10.2, parallel lines, perpendicular lines, and related angles, including the related angles formed by parallel lines and related angles formed by perpendicular lines. So this is an example of parallel line. This is the zebra crossing on the road and railroad tracks. So parallel lines are lines that never intersect. They are same distance apart. As this picture shows, these are some characteristics of parallel lines. They are in the same plane and never intersect. Always the same distance apart, have the same slope, and the symbol is something like 11. Like as this shows, this is a parallel line. But if it is slanted, then it's not. So this is an irrelated angle formed by parallel lines. So if two lines which are parallel and intersected by a transversal, it will form three angles, which are corresponding angles, alternate angles, and interior angles. So firstly, corresponding angles. It is one of the type of angles that are formed when two parallel lines are intersected by the transversal. In this picture shown, these two are the corresponding angles, which angle 1 are equal to angle 2. So the characteristic of corresponding angle is that one of them is interior and another is exterior. This one is interior and this one is exterior. They are on the same side of the transversal and they are not at the same vertex. If you want to find a corresponding angle, look for the abstract. So this is an alternate angle. They don't have the same vertices and fall on the alternate side of the transversal. For this one, this angle has these vertices and the other has these vertices, which they are not the same. They are equally measured, and if you want to find an alternate angle, look for the Z shape. This is two pictures shown. Though that one this is an acute angle, one is an obtuse angle, but both are alternate angle. Next, co-interior angle, also known as consecutive interior angle, are two angles that are on the same side of the transversal formed when two parallel lines, which are these blue lines, are intersected by the transversal. This orange is the transversal. And in this picture shown, angle 1 plus angle 4 equals to 180 degrees, and angle 2 plus angle 3 equals to 180 degrees also. The two interior angles are only equal when they are both 90 degrees. They have a sum of 180 degrees for co-interior angle. If you want to find a co-interior angle, look for the C shape. Okay, this is the example. In this picture shown, you can find all of the corresponding angle, alternate angle, and co-interior angle. You can find 4 corresponding angles, 2 alternate angle, and 2 co-interior angle. Now we move on to perpendicular lines. Perpendicular line intersect at 90 degree angle, forming a square corner in this picture shown. If if the angle that formed is not at 90 degree angle, it's not a perpendicular line. So the characteristic of a perpendicular line are in the same plane and always intersect at 90 degree angle, which is a right angle, and the symbol is an upside down T. For example of perpendicular line in real life are this letter T, and the side of that square, also like this whiteboard, like this one, intersect at 90 degree angle also. So there's only one angle that are related with perpendicular line, which is the right angle. In a right angle is an angle of exact 90 degrees. Less one or more 1 degree is not a right angle. Furthermore, in a right angle, two straight lines are perpendicular to each other at the intersection. A square or rectangle consists of 4 corners with right angle. Okay, so now we are going to talk about chapter 10.3, which is congruent figures. Next slide. Firstly, what are congruent figures? So if two figures can be placed precisely over each other, they are said to be congruent figures. The term congruent here means exactly equal shape and size. This shape and size should remain the same, even when we flip, turn, or rotate the shapes. The corresponding sides and the corresponding angles of the shapes are also the same. For example, here you can see that the blue shape is congruent to the yellow shape. Next slide. Here are some examples. As you can see here, these two quadrilaterals are congruent, and the red shape has been reflected to give the blue shape. So they are still of the same shape and size. Now the second example here, we can clearly see that these two polygons are congruent. They are the same shape and size. Now the third example here, these two polygons are congruent, and the red shape has been rotated to give the blue shape. So they are still the same shape and size. Now for the last example here, you can see that these two polygons are not congruent. They are just similar shapes. This is because the red shape has been enlarged to give the blue shape. So even though their shape is the same, but their size is different. Hence, they are not congruent figures. Now let's look at the symbol of congruence. Congruence is represented by this symbol here. Since congruence in objects implies equal shape and size, the symbol of congruence is made of two symbols, one above the other. There is this symbol here, which is called the symbol of tilde, which represents similarity in shape, and the equal sign here represents equality in size. Now congruence is represented by this symbol here, because congruence means that they are same in shape and also same in size. Now if two objects A and B are congruent to each other, we can write it as this. Next slide. How do we recognize congruent shapes? Now firstly, we need to check the type of 2D shape. And secondly, we check the type of corresponding angles and corresponding sides. And lastly, we state if the shapes are congruent or not. Let's look at an example here. We can see that there are two shapes here. Are these 2D shapes congruent? Now as said before, firstly we check the type of 2D shape. And we can see that both of the shapes are rectangles. Now we check the corresponding angle and the corresponding sides. Now we can see that all of the angles here are exactly 90 degrees. And the short sides on both rectangles are 1, and the long sides on both rectangles are 3, as you can see here. Now this proves that the shapes are congruent because they are the same shape and size. Let's look at a second example here. There are another set of shapes, and are these 2D shapes congruent? As mentioned before, we check the type of 2D shape, and you can still see that both of the shapes are rectangles. Now we check the corresponding angle and the corresponding sides. We can see that all the angles are exactly 90 degrees, so they are of the same angle, and the short sides on both rectangles are 2. But you can see here that the long sides are different, because the long sides on the pink triangle here is 4, but on the blue rectangle it is 3. So the shapes are both rectangles, but they are not congruent shapes because they are of different shape and size. Now I have an example here. So we can see that both of the triangles are equilateral triangles. They are 60 degrees here and they are 10 cm. So both of them are congruent figures because they are of the same shape and the same size. But this triangle here, even though they are all 3 equilateral triangles, but this is not congruent because it's not the same size. As we can see here, this is 6 cm and this one here is 10 cm. So these two shapes are congruent to each other, but this is not.
So the next topic we're talking about is line symmetry. So line symmetry is a line of symmetry is a line that divides a shape or object into two equal and symmetrical parts. Like this one, like it can divide into the exact same shape. It's also called the axis of symmetry or the mirror line because it looks like mirror reflections of each other. The number of symmetrical lines in the shape of figure varies and depends on the type of shape. Like here is all different. Square has 4 lines of symmetry, rectangle has 2, but parallelogram has none. Fun fact, a circle has an infinite number of symmetrical lines. So the line symmetry of polygons, in polygons, that the number of lines of symmetry in a regular polygon is equal to the number of sides in a new polygon. So an equilateral triangle has 3 sides, so there's 3 lines of symmetry. In a regular pentagon, there's 5 sides, so there's 5 lines of symmetry.
So now I'll be diving into the topic rotational symmetry. Rotational symmetry is when an object is rotated on its own axis, the shape of the object looks the same as the original. The order of rotational symmetry is the number of times an object matches its original outline through rotation. Many geometrical shapes appear to be symmetrical when they are rotated 180 degrees. Okay, so let's look at this example right here. As we turn this plus sign to 90 degrees, it looks identical as the original one. Therefore, it consists of a rotational symmetry. And for this shape, if you turn it 90 degrees, you'll see that it's not identical as the first original image. So therefore, it doesn't consist of a turning symmetry or rotational symmetry. Reference for rotational symmetry. As you can see, the square shape as turned every 90 degrees is the same as the original. That concludes that it has 4 rotational symmetry of orders. The order of rotational rotation in geometry indicates how many times a shape can be rotated 360 degrees while maintaining its original appearance. Let's look at this reference also. The star shape, as it's rotated 90 degrees, it looks the same as the original image. While the butterfly shape, as it keeps rotating 90 degrees, it doesn't look identical as the first image. Rotational symmetry of polygons. Square, it has a rotational symmetry of 4, while rectangle has an order of 2, rhombus with an order of 2 as well, pipe order of 1, parallelogram order of 2, equilateral triangle 3, isosceles trapezium 1, and hexagon 6. So I have a plot right here. You see, as it's turned 90 degrees, it will look different from its first image. So as we turn it again, it looks identical as the first one. And we turn it 90 degrees again, it doesn't look identical to the original image. And lastly, as we turn back, it looks identical. So it has two rotational symmetry.
And now I'll be presenting 10.6 Polygons and Circles. In this topic, I'll be covering types of polygons and its properties, circles, and parts of circles. What are polygons? Polygons are a shape which all the sides are the same and also with the same length. There are many types of polygons, and their characteristics are they have fixed external angle, which is 360 degrees, and all the interior angles are fixed. For example, quadrilateral, or we also call as square, have a 90-degree interior angle, and for pentagon, it has a 108-degree angle. As shown, triangle has the least number of sides, which is 3 sides, and each of the sides have a 60-degree angle, which is also considered as an acute angle. The sum of all the interior angles are 180 degrees. As shown here, this is an equilateral triangle, as mentioned by Yu Zhe just now. And for the quadrilateral, which is this, it has 4 equal sides, and each of the interior angles have a 90 degree, and the sum of all the interior angles are 360 degrees. And for the pentagon, it has 5 equal sides, 5 vertices, and 5 interior angles. Each of the interior angles have a 180 degree, and the sum of all of it is 540 degrees, as shown here. And for hexagon, it has 6 equal sides, 6 vertices, and 6 interior angles. As shown here, each of the interior angles have 120 degrees, and the sum of all of the interior angles are 720 degrees. And for hexagon, it has 7 equal sides, 7 vertices, and 7 interior angles, and each of the angles have 138.57 degrees, and the sum of all the interior angles are 900 degrees. And for octagon, it has 6 equal sides, 6 vertices, and 6 interior angles. Each of the angles consists of 155 degrees, and the sum of all of it is 1080 degrees. And for nonagon, it has 9 equal sides, 9 vertices, and 9 interior angles. Each of the interior angles have 140 degrees, and the sum of all of it is 1260 degrees. And lastly, for the decagon, it has 10 equal sides, 10 vertices, and 10 interior angles. Each of the interior angles consists of 144 degrees, and the sum of all of it is 1440 degrees. And for circles, it is a round shaped figure that has no corners or edges, not like the polygons. And there are many parts of the circles. For example, the center, which is this dot here, and for the radius, which is a constant distance from its center, from the here's the center, and now here from the center to the end of the circle, it's the radius. And now for a diameter, it's a chord that passes through the center of the circle, which is here. And for the arc, it's just like a small and big triangle, or a small and big flat pizza, as shown here. From the center to here's the minor arc, and here's the major arc, which is the bigger ones outside the line. And now for the segment, it is a line that doesn't pass through the center of the circle. It is not like the diameter which passes through the center, and it is not very and lastly, for tangent to a circle, it's a line that touches the circle at a single point, which is here, like this. And lastly, is the sector. It's the space inside the section of the circle created by two lines, which connects the center. Usually, the major sector has more than 180 degrees, as shown here, the major sector. And the minor sector has less than 180 degrees, which is here.
Okay, now lastly, I will be diving into 10.7 3D shapes, plans and elevations. I will cover introduction to 3D shapes, different types of view perspectives, drawing, plan and elevation, and constructing a 3D object. So firstly, what is a 3D shape? 3D shapes are objects that have 3 dimensions, which is length, width, and height, while 2D shape has only length and width. All 3D shapes are solid, unlike 2D shapes which only appear on a flat surface. Okay, so next, plan and elevation. So, plan view. Plan view basically means that having a top-down view upon an object. It shows us the layout of the object and gives us an horizontal projection. So for example, this one, the plan view is having a top-down view of this 3D object. So the plan view, we would see 2 boxes, as shown here. So next, elevation view. Elevation view offers a front-facing view of an object, and it helps us to understand the external aspects of an object. So, elevation view includes front elevation and side elevation. Front elevation basically means front view, and side elevation basically means side view. So as you can see here, the front view is an L shape, like this, and the side elevation is also made of 2 vertical boxes. So next, drawing, plan and elevation. So firstly, the most important part, we need to identify the plan view, side elevation, and front elevation first. Then we can refer to the object and draw out the plan view, front elevation, and side elevation. So this would be the plan view, front elevation, and side elevation for this object. So next, constructing a 3D object. So it will be first the plan view, front elevation, and side elevation. We need to construct the 3D object out of this. So firstly, we observe the plan view. We can tell that the shape has an L shape. Next, we observe the front elevation. It tells us that the 3D shape is 3 blocks high and 2 blocks wide. Lastly, observe the side elevation. We can confirm that the 3D shape is 3 blocks high by looking at the side elevation. And now we can draw the shape. Remember, the front elevation and side elevation always follow the direction of the plan view. So it means that the front elevation will be here, the L shape will be here, and side elevation will be here. So
So this would be the 3D object for this. So next, I will give you plan view, front elevation, and side elevation. I will pick one student to come out and draw the 3D object. Next. Okay, so anyone want to volunteer to draw out this 3D object?
No volunteers? Then we'll pick one.
Center. Opposite. So the plan view, the front elevation, the side elevation, the front elevation. The 3D object. 你大概看到。
They are the same object. It's just from different views.
The front elevation would be here. So you can see that the front elevation is 2 blocks. The plan view would be here, and the side elevation would be here. So that's all for me. Okay, so that's all for our presentation. Thank you. 3, 2, 1, bye.